The purpose of this video is to give you some background information on the first topic that we'll be looking at in Unit 1 on biogeochemical cycles, and an activity that you can look at. If you don't already have your CED out, you can turn to this section in your binder or in your PDF. We're really going to focus today in the pre-lab on nitrogen and phosphorus. All of the biogeochemical cycles center around the big idea of interaction between Earth systems. The Earth is one big interconnected system. Systems change over time and space, and these biogeochemical systems vary in their ability to recover from human disturbances or natural disturbances. The practice that we're going to really focus on kind of makes sense, visual representations, since we'll be looking at a model or diagram of all of the different cycles. Just to give you a little bit of frame or context of our history with biogeochemical cycles, for those of you that are experienced, we used to have a lot of random knowledge that we would make students memorize all these terms, denitrification, ammonification, nitrogen fixation, and they'd have to know all these polyatomic ions and formulas of these compounds. And of course it was really difficult for them because they had no experience or content to stick all of that kind of random knowledge to. So as you look at the specific essential knowledge statements in each of your specific topic pages for 1.5 and 1.6, they look very similar. Think about the big idea and this enduring understanding, this really big takeaway. And that's what we want students to be able to understand in this first unit where we introduce biogeochemical cycles. We're going to come back to these cycles in our unit on food agriculture, in our unit on mining, in our unit on aquatic pollution, and we will constantly be building and adding more content so that by the end of the year, students will have a very rich understanding, and that big idea and essential knowledge statement are really going to make sense to them. This bulleted point, initially, biogeochemical cycles facilitate acquisition and transfer of energy into usable forms. As we move through Unit 1 in our first live session and go from cycling to food chains and food webs, that's where they're really going to start to master that target idea. And then kind of what the students are going to need to be able to do with that information. So just a quick overview on the phosphorus cycle. Describe the movement of phosphorus atoms between sources and sinks. You'll realize very quickly, I haven't introduced task verbs yet from a free response essay question, but I'm just going to start using them. We want students to be able to describe the movement of phosphorus between sources and sinks. So instead of memorizing a bunch of random details, can they describe this process? Rock weathers or breaks down. Plants are able to take up that phosphorus. It's an inorganic form of phosphorus. I don't care if they can tell me if it's PO4, 3-, or what it is. It's an inorganic form of phosphorus that came from an abiotic component of the environment. So that rock is broken down. Plants are then able to take up that inorganic phosphorus and assimilate it, turn it into an organic biotic molecule, if you will, that like DNA. That animal eats a plant and gets its phosphorus that way. The animal can then urinate or defecate and put that phosphorus right back in the soil to be taken up by a plant again, or that phosphorus can run off where it will really slowly, on a geologic time scale, on a long time scale, be incorporated back into sedimentary rock, and then maybe that sedimentary rock is uplifted and can wear down or weather again to release more phosphorus. The kind of main points that we want students to understand, other than describing that simple process, is that the main reservoirs of phosphorus are rock and sediment that contain these phosphorus containing minerals. Again, we come back to that in mining and other units. And there's no atmospheric component of the phosphorus cycle. And this limitation, the limitations this imposes, means that phosphorus is really sometimes challenging or difficult for plants to get. That statement might not make a lot of sense to students right now, but when they learn about the nitrogen cycle, for example, and can compare it to the nitrogen cycle, then that statement starts to make more sense. A little wonky on my animations here. So describe the movement of nitrogen atoms between sources and sinks. The atmosphere is a major sink or storage reservoir for nitrogen. Plants can't diffuse gaseous nitrogen through their leaves like they can CO2. That's a big concept for students to get. I like to say big idea. They do, if you look at the essential knowledge statements, need to know the term nitrogen fixation, and that is accomplished by symbiotic bacteria that live in plants like a soybean, like a legume. Just like plants had to assimilate that inorganic form of nitrogen into an organic form, like they did for phosphorus, they have to do the same thing for nitrogen. That animal gets its nitrogen from eating a plant. That animal poops, and that nitrogen is returned to the soil so that it can be taken up by a plant again. Most reservoirs of the nitrogen cycle hold those compounds for a really short period of time. Now this makes more sense that the phosphorus cycle holds elements for a longer period of time. You can talk to your students about a comparison. In terms of disruptions to the nitrogen cycle, this is just a super good example of spiraling. We're going to look at how nitrogen-containing minerals in fossil fuels are released as nitrogen oxide gases when I burn them. When I apply nitrogen-based fertilizer or livestock waste to an agricultural field, I am altering how that nitrogen moves through the nitrogen cycle. I'm accumulating it all in one area. That excess nitrogen or phosphorus could run off and enter an aquatic ecosystem and lead to eutrophication. So again, just to reiterate, I really am laying the groundwork. Can they get that overarching idea about what happens during a biogeochemical cycle? All matter cycles, we are a closed system for matter, and it's going back and forth from a biotic to an abiotic form. Here's an example of an assessment question then. You can stop the video and process this because I'm going to go through it super quick. Here's another task verb. Identify the process. There's only this one set of downward arrow going to a legume, and this is where they would want me to know that term nitrogen fixation. A multiple choice question. Again, stop the video and process it if you'd like. Which cycle is being represented in the diagram? And the student should easily pick out the phosphorus cycle. This is a little bit more advanced skill. So practice, we'll come back and look at that practice in a second. There's no gaseous phase here. That's as I'm going through and modeling how to solve a question with students together like this, that's one of the things that we want to point out to them. And I've got all of this weathering of rock. That was that phosphorus, that very slow cycle. Here is yet a more advanced scaffold of that skill of visual representation. Again, read the question and process it. But really what they're saying is, if this farmer's using no-till agriculture on their agricultural land, which of the following would be the long-term effect on the ecosystem surrounding the farmland? And the students should have picked up that there would be less algal growth in the nearby ocean. This is where they're getting into the highest scaffold level of that science practice. Explain how that concept and process relates to a broader environmental issue. So giving you some examples to illustrate. And throughout the unit, you want to walk your students through looking at diagrams and progressively advancing how they are able to process what's going on in that visual representation. We do a ton of this throughout the week. What I would like you to spend a little bit of time doing is going to the Serengeti nutrient cycling activity on HHMI Biointeractive. It's a spin-off of the movie and film, The Serengeti Rules. That's the trailer. You can buy it on Amazon if you'd like. Check it out. We can talk about it in our first live session. So here's the 60-second version of what's going on here. There's background information that the students will read. There's an activity. We called it kind of a placemat when we were developing this activity. And I use it in this teaching strategy I call ABC, activity before content. I am not lecturing even on biogeochemical cycles. I tell students we're going to talk about how elements cycle through the biotic and abiotic components of an ecosystem, and I'm going to introduce that content to you with an activity. So what they do is they pick up a process card. This process card says that animals eat organic compounds. So this is a lion eating maybe a wildebeest for energy, and they respire carbon dioxide. They are uptaking carbon, and 6 units of carbon. Notice they didn't get any phosphorus or nitrogen during this process, because this is the process of cellular respiration, going from an organic to an inorganic form of carbon. Here's another process. Inorganic minerals leach into the groundwater. This is an example where I'm going to get 1 unit of phosphorus. And the very cool part of the activity is that students need to draw soil microbe cards. The bacteria decompose complex organic matter into inorganic forms, which are available for plant uptake. And so a lot of times they can't do a particular process unless it says, oh, can't do this unless you have a microbe card. Notice here that the wildebeest graze and defecate, and there's all kinds of nutrients available. When an animal eats something and then poops it out, I get carbon, nitrogen, and phosphorus, but I don't get access to those elements unless I have a soil microbe card to pair with it. And so just a quick sampling of the type of questions that they ask. This is what we really want students to know, right? This is a big takeaway that we want them to answer about biogeochemical cycles. They also get, from looking at their little, their activity piece here, that boy, they don't need a lot of phosphorus, but it's pretty hard to get. And so they understand that phosphorus is often a limiting reagent. They talk about that soil microbe card and the role of it. And then this is just a great question that HHMI throws out there. Do you think other ecosystems cycle nutrients in the same way? And this is what I would use then as my discussion question as a whole class to get kids see their ideas and see what they have to say. So it's a super fun activity. Have some fun with that. And I will see you in our live session where we're going to dig into the carbon cycle. Have a great rest of your day, everyone.